We're going to start our circuit lab using the Vernier circuit board. We are going to limit our power to 2 D-cell batteries in series with one another for a total of a 3-volt potential difference. And you can see that they fit right into the battery holder on the circuit board. So let's just take a quick look at some of the elements of the circuit board that we'll be utilizing. One is the switch right here. The switch is going to be in the on position when you switch it to the 3-volt spot there. The next thing that you're going to want to take note of is the positive or high potential post and the low potential or negative post. They correspond with the positive terminal and negative terminal of a battery. So that's where we're going to use. That's what we're going to use as our landmarks for the high and low ends of our circuit. So up here we have an array of resistors. We're probably going to be just using a couple of them. There's also some light sockets here. We have various different light bulbs that we can use in those. And you can see these silver little posts that are associated with each of these circuit elements, and those posts are connection points that we can use alligator clip wires, connecting wires to make connections between the elements. So let's move on to the next slide. Alright, so here I have set up a circuit, and let's just see if we can follow the current from high potential here to low potential there. I know you can't see the entire wires, but I'll kind of walk you through it. So we know that the conventional current, or the current that would be associated with positive charge, starts here at the high potential, goes through the wires, through this first resistor, connecting wire, second resistor, and back down to the low potential here. So that's one path, so we know we have a series circuit. We could go through and figure out, well, what is our total resistance? We could add up the values of our two resistors here, determine that resistance, the equivalent resistance of our circuit. We could say, well, we've got a 3-volt supply here, so 3 volts, and then we've got, I think it's a total of 78 ohms, yeah, 78 ohms there, and you could calculate what your ideal or your predicted current would be. But how would you be able to test your prediction? Well, what we're going to be able to do is to use a multimeter to do that. Now, we could use the Vernier voltage and current probes, but we're going to just try a plain old digital multimeter to make some measurements lab. So this is what our multimeter looks like. Right here is where we're going to insert the red probe, the positive terminal probe, and here is where we insert the negative end. And this is really important that you do the red and the black in the order that I show you here, because the red is always going to be your higher potential than the black. So basically when you're measuring, for example, current, this end of this, this end of the probe here, let's see, this end of the probe here is going to be actually physically wired into your circuit at a higher potential than this end of the probe. So when you measure current, you're actually going to undo your circuit a little bit. You're going to insert this whole setup into your circuit in series with the rest of the circuit to get a current reading. But before you do that, you need to make sure. So what we can see here is, again, we're at the 10 ADC port and the COM port here, and I've also wanted you to note that I'm at the 10 amp position on the dial. Okay, so now I've got this set up so that it's the same circuit that you originally saw, and now here I have wired in, if you can, I don't know how well you can see it, but remember the current we followed through the resistors. Alright, now when we get to here on this resistor post, the post that goes with this resistor, you can see I've replaced the alligator clip from that white cord, or I'm sorry, from the black cord. I've replaced it with the actual probe. Alright, that's the needle end of that red probe, and it's just kind of resting there. You would hold it there. I was trying to do all this myself with the camera in one hand and the device in the other. And now if you look in the foreground, you can see that I've clamped the black clip that used to be up here on this post. That's now on my low potential probe tip. So then if you can think about it, you've got the current from the battery through the red wire, through the first resistor, through the white wire, through the second resistor, through the red probe wire into my meter, and then through the black and down to ground. All right, back again through the meter, but into back to ground in the circuit. And you can see here I've got a reading of 0.04 amps. That's to measure current. So it's really, really important. High potential to low potential, you actually wire the multimeter into the circuit for measuring current. All right, and here's just a different view of that. All right, so suppose now I want to measure the voltage or the potential drop across a certain part of my circuit. Well, I could see that I've had to rearrange my multimeter a little bit. I've moved the red probe end into this port. Here it says V ohms MA, but that's where you have to place that. And then you can see that I've got still the black one in the COM port. But now, notice I've changed the dial up here to 20 on the DCV end of the dial, or part of the dial. And here this is in action now. Unlike measuring current, when you measure voltage, you want to actually take the probe and measure across the section. You don't want to put it in line. You don't want to put it actually in series with the elements. You don't need to disconnect anything from your circuit. You simply take the probe, the high voltage end of the probe, or the red probe needle, at the higher voltage end of the higher potential end of the element that you're interested in, and that you can see that probe needle is just touching that post, the same post that the white wire is connected to on that second resistor. And then here you can see the black wire is still connected to the resistor, and that's the wire that's carrying the current back down to ground. But, and I know you can't see it quite as well, this is the black probe needle, and it's actually just sitting right there on top of that post, is just like the red one is. So now instead of running current through, I'm just getting a potential difference across. And you can see up here I've got a reading of 2.65 volts. Okay, so that tells me that there's a potential drop of 2.65 volts across that resistor. Now you can do some math in your head. If I have a 3-volt battery and I've got 2 resistors in series, then the rest of the voltage drop must have occurred across that first resistor, and you could kind of figure out what that should have been. All right, now when you're trying to wire in parallel, that gets a little tricky with the size of this board and the way that the posts, so they're not real tall, so it's difficult to fit more than 2 clamps on them at once. So what I've done here, just as an idea, is I've connected my high potential post to this red alligator clip here. So I've got current running through there. All right, and here I've just connected 2 separate green wires, one that is wired to the second resistor here, the other that's wired to this top resistor here. So now I've got my main current should be splitting into 2 currents running parallel. Now, how do I connect those to ground? Well, over here at the other post of that top resistor, I've got a white wire going to ground here, and there's a second white wire connected to the other resistor going to ground. Now look what I've done here. Same thing I did on the opposite end. I've got the 2 wires, the 2 white wires from those 2 separate currents clipped to one black alligator clamp, and that is connected to the wire that's going to ground. So sometimes it's easier just to make those connections outside of the circuit board because these posts are a little bit stubby, so it's kind of difficult to do that all on the board. And this will work just fine. But again, if you need to measure, say you wanted to measure the current in this wire here, you would have to disconnect this wire. You would put your multimeter into the circuit. The red probe would stick to that post, where it would be placed on that post, and the black probe you could clamp right into this alligator clamp. To measure the voltage across this resistor, you wouldn't unclamp anything. You would just take the red probe here, the black probe needle there, and you get your reading. How do I know which end is red, which end is black? Well, this is the higher end of the circuit. And that's it. Good luck with your lab.